So to make our view model more of a gatekeeper, right, not just this sort of pass-through that's not really doing anything, let's take a look at how to do that. The first thing we need to do, well, is actually limit access to this model, right? We don't want everything to have access to this model, and we want to instead have the view model sort of manipulate data in the model first, and then control when and how we share it out. So the first thing that we do, very simply, is to make this private. And that, right, that solves our design pattern problem, right? So now we have the model inside the view model, but the views cannot access it directly. And they're going to need to access some other way to do it. So let's make some sort of specialized ways to access this model. So these will be our sort of public vars or available vars that are available to the view. And we do want this sort of feed of posts, right? We want like public posts or something like that. So we'll say Pokemon posts. And this is an array of posts. And we're not going to set the variable, right, like we might normally did, but we're going to do kind of what SwiftUI does. We're going to use a computed variable. So we use a bracket. And what's nice about that is that means this function, whatever goes on inside here, is going to run. And each time that this is called, that will run this function, and it can be dynamic in that sense. So for example, we will connect it to the model, right? Because the view model can still see the model. We just don't want the views to see it. And then we'll connect it to posts. So now we have separated this model. We made it private, but we have this sort of variable that will update when these posts update, and it will reflect. And this is just a one-way connection, right? So this published gives us a two-way connection here, but in this case, this is just a one-way that's updating the posts. And to use that, if we go to our list, right, so this will not work anymore because we no longer see the model. But instead, we can see that, Pokemon posts. And what's nice is it's a little bit more verbose in telling us, what it is and how it's being used in maybe this specific view context, right? Again, in this app is so simple and everything, it may seem like, well, why am I doing this? And it's true, in an app this simple, you don't really need to do it. But if you can imagine these things getting more complicated, this is the template that helps you manage that complication and keep things organized. So, okay, we have successfully separated our concerns, which is nice. And this will still respond to the model by way of the view model, but it's just a one-way connection. And that's all being managed here. But what about if I want to make a change, right? What if I want, in my view, the user taps a button, something like that, and we want the model to update. We want to make a change. How do we do that? Well, there's an example where we do just this, right? So inside of our row, our Pokemon row, we have, if I can find it here, oh, we don't have because I haven't created it yet. Okay. Yeah, okay. I thought it was already made. Okay. Too many demo projects in different stages. All right, so let's say we want to make a change to something, right? Well, we might want to add a button, right, to favorite a Pokemon, right? This has been kind of like a star button. We did this in the Landmarks app, and you do it in your Solargram homework. It's sort of common to have this star button. And that is something that would affect the model, right? But it's from the view. And so how do we translate that across? Well, let us create our button. And the way that we're going to create our button here, we already have this nice Z stack. We have an image and then this H stack, right, with our label. This is sort of the design we're going. And it would be nice to put this button on top and in the upper right hand corner. That's kind of where I want this button to go. This H stack, right, it's already aligned bottom. So this H stack, and because of the spacer, is in the lower left corner. So how do we get to in the upper right corner? Well, we want another Z stack with a different alignment on top of and mapped to this existing Z stack already. And an easy way to do that is something called overlay. And so by creating an overlay, this sort of creates like a unique Z stack, like a limited Z stack that goes on top of whatever your existing thing is. So you can overlay anything, an H stack, V stack, a square, a rectangle, whatever. You can overlay anything. In this case, I'm actually overlaying a Z stack. You might say, well, why do I need to do that? Well, because I want to change the alignment. And so in this case, we want to use top alignment. And then we'll have our content here. Now also notice the autocomplete, the syntax here, it actually says content. It has this open bracket, closing bracket, and then there's a parentheses because we're still inside the parentheses. And you can see this is how it's just passing an argument inside this function. And that's the same how like Z-stack might work, something like that, but it looks different. Why? Well, this is the more explicit view, and this is the shorthand view, right? Where the closing parentheses is here, and it doesn't say content anywhere. It just has the square bracket. So we can go ahead and transfer this to the shorthand because that's sort of common and just easier. But here you can see what it does look like. So to do that, we remove this, right? And then we actually remove the content, remove that. We don't need the comma anymore, but we do need to close the parentheses. So we close the parentheses, which completes that thing, and there's this hidden, Swift magic syntax sugar. It's like a known shorthand that says if you have a closure as the last parameter in your struct or function or whatever, then you can use this shorthand. And so it goes outside of the closing parentheses like this, instead of, right, content like this and this. So that is the explicit, sort of verbose way, and then we have the implicit, simpler way. All right, so that was a little tangent, but maybe helpful. So now in our overlay, we want another H stack. And since we want on the right-hand side, we're going to start with a spacer. And then we're going to create our button. And we can go ahead and use this autocomplete, which gives us the action in the first closure and the label in the second closure. And you notice there's actually quite a few ways to define a button, but I like this way. This is sort of the simplest. And so if we press enter, it completes both of those. And you notice it used the shorthand for both of these things. So it actually has two closures. Since it has two, the second one does need a label. So the first one, the label is hidden. This would be the action. But the second one, which is label that happens to be called label, that's just a coincidence because it's the button label. But this is also I guess it'd be the parameter name, right? Or the label of the function, which is here. Okay, so the action that we would have this do, well, normally we would say something like post is favorite toggle. Okay, well, so there's already one problem. Our post doesn't yet have the ability to be a favorite. So in our model, we want to go here and we would say var is favorite bool, right? So we want a Boolean to track whether the post is favorite. And we need one for the post because each post could be favorite or could not be. Okay, so now we can do that. We can toggle it. And then let's get a label for our button. And we will say, well, if the post is favorite, then we want the filled star, right? Star fill. And this is just like how they do it in the Apple Landmarks app. But if the post is not, then it's going to be the system name, just star, not filled, because it's not yet favorited. So we have a button, we have a way, an image, which is sort of what our button looks like, and it will respond, right? Because we've hooked it up. This post, it will respond to the changes and sort of be laid out that way. And just to kind of make it look pretty and match the theme, we might say foreground color. Uh-oh. What did I do wrong? Do I have a missing if else? No, I think that's right. Not sure why it's throwing that error. Okay. We want a foreground color. And this is just the, this app happens to use each post as a color, and that kind of manipulates the theme. And you already see that here, right? When we do this rounded rectangle with the post color. So this will just make sure we're matching the theme that we have. All right. So the one curious thing is we know we can respond to changes because we get the post here, right? And this post is coming from this view model. And the view model is this kind of thing, which ultimately gets it from the model. But are we going to be able to make a change there? Like, will we, can we toggle this favorite? Let's go ahead and run it and find out. Okay, failed. Probably for a couple of reasons. Let's see, what do we got here? Oh, well, because I updated favorite, but I haven't set our dummy data, right? This is our dummy data that needs a default value. So I could set it for each one, but I could also give a default value here. And we'll just say, you know what, the default is false. And let's try to run it again. And great, so all those errors went away. Instead of manually typing false for each one, we just gave a default value in the declaration so that it's assumed if I don't explicitly say, then it goes to the default. So that's nice. All right, but we have some other problem. Interesting. So in this case, right, I am trying to toggle the state of the favorite, which is a mutating thing, right? I'm mutating a thing, but look at this. Cannot use mutating member on immutable member self. Self is immutable. What the heck does that mean? Why is it immutable? Well, it's because this is just a var, right? This is a var connected to a view. Now we know that this is passed into us from the view model and all that, but the way it's defined, it's just a var. And since views are structs that are immutable, don't change, it doesn't allow this. This is not valid. Now, what you did in the past, right, was you would just say, well, okay, it's a binding, right? And we want to say it's a binding, and that gives it a two-way connection, right? That gives it some access to some state. And it's true if we build this, that error goes away. We now have a different error. So that, because now we have a binding, and that's fine, okay. But the problem is now this is expecting a binding, and we're not giving it a binding. We're just giving it a regular post, because these are just regular posts. And so even if you try to pass a $, something like that, that won't work because this ultimately is not a binding. It's just a regular old variable. So there are a couple ways you could do this. And to be completely honest, I'm not yet convinced which is the best way. I've been taught a couple different ways. I've used different ways in my own projects. And there's pros and cons to these different ways. And I'm not yet convinced on the best way. So this is something I'm still kind of searching because it just depends on other factors. So one way is to make this a binding, right? And there'd be different ways to do that. I'm not going to look at that approach in this video just because I'm going to share like the way that I was taught how to do this. And so we're just going to go with this one approach. But full disclosure, I'm not yet convinced this is the best approach, but it does seem like a good one. And this is the one that Stanford teaches. That was one I was taught, so it's what I'm going to teach you. But if you wanted to like discuss the nuances of this, we can have that conversation. So what we're going to do is recognize that this is not a binding because we want to control the state. We actually want to say this is only a read-only view. We don't want to write. We don't want it to be so easy to write to the model. It's just a read of the model, and it updates when the model updates. And the reason is we really want to control mutations in the mutable state to only happen inside of the model. So what instead, we want a whole other thing. We want a way to track whenever we give mutations. So we call these intents because they're like intents from the user. They're things that the user wants to do that may or may not change the model. In this case, it is an intent from the user, right? Because the user tapped that favorite button. So that's the intent. The intent part is the user tapping, swiping, clicking, whatever. And in this case, the intent is going to change the model. So what this lets us do is group and organize where these mutating funcs are. And so we're going to create a function to handle this intent. Even though it's so simple, you're just toggling the Boolean. We're going to create a function to handle this. So we will say set post favorite. And we're going to have it passed a post in because it needs some kind of post to be set as the favorite. And if we go back to where we use this, so we're not going to use a binding. And we need to go all the way back to the row. All right, so now we're looking at the Pokemon row. And we're not going to toggle it here. We're going to do that somewhere else. And so instead what we're going to do is, if you remember, we have this view model that's part of the environment, and we also have it in this row. And you're like, well, why did I do that? We haven't used it yet. Well, this is where we're going to use it. So I can say view model. And you notice now I can say set post favorite. And maybe you call this toggle post favorite, or I don't know, but it is sort of, the user's setting. They're setting it, they're unsetting it, so I think it works. And then we actually pass the post. So we have this function, and now we pass the post. And what's important, right, is there could be many, many rows. This is just one row, right, and it has a post, but there could be many, many of these. And what this is doing is it's passing that specific row that the user is tapping on to make sure only that specific one gets sent over. Okay, so now this is great because now there is no state change happening in the view, right? It's just saying, hey, view model, figure it out, right? Here's a function. I don't know how you do it. I don't care how you do it. Figure out how to set this post as a favorite. And okay, here's the post that I want set favorite. And that's why this approach, I think, is favored and traditional, and it's good. Is it separates that concerns. The view doesn't care how you accomplish this. Just call the function and figure it out. All right, so we have to figure that out. So in our view model, we have this function, and it needs to somehow set the post as favorite. And so you could do the logic in here, and you could start manipulating the model and things, but that's not really the point of the view model either. This is something the model should do itself, right? Any view or whatever could call different things, but manipulating state of the model should be done internally. It should be done itself. And so the view model, it just wants to pass this intent along. And so it wants to say, hey, model, you should like set, like the post or something. You should do something like that. So that means we need to create a function on the model, and we're just going to pass this along. And so basically the view model is, it's like, hey, I don't want to deal with that either. Let's pass along the responsibility. Because when we deal with state, the model should handle that, right? It's our one source of truth, our one source of state. So that's going to happen here. So we have this variable, but you know what? This is in a struct, because this struct defines our whole model. And that means we can add functions to it. So we would say set post favorite. But as I think about it, when the view model, we call it set post favorite because maybe they're setting it, they're unsetting it. It's that user intent. But when we get to the model itself, we're kind of abstracted away from setting or unsetting. So maybe I think in this case, it is better to use toggle, because that's exactly what it's doing. All we want this function, we don't know how or who is telling it to toggle. We just want it to toggle the favorite. So I think we will use that verbiage here. Again, this is up to your personal preference, but this is how I think about it and why I'm doing it this way. This is exactly what it's doing. And, I decided, so we have a post, and we're going to have to pass in a post. But the other thing is sometimes when it's in this case, right, it's the Pokemon post manager. So it's sort of implied that if we're toggling the favorite, we're doing it to a post. And so this underscore means you don't need this name in the function call. You'll see what I mean shortly. So when we do it like that, color changes. And so that means when we write it here, we just say model toggle post. And that's it. We don't have to do the whole like post equals post. Arguably, here we do say set post favorite post. So I don't know. You could either maybe change it like that, or you could do the underscore here. Maybe it's implied as well. But I'll just leave it so that you can see both. And this is all personal preference, right? But the important thing is to make it clear and something that makes sense to you and your teammates. All right. So we got the function call. We've passed along from our view to our view model and now into the model itself. So now this is where we actually need to do the logic of toggling this dang thing. All right, so we finally have it. So don't we just get to say post is favorite toggle? That would be nice, right? Well, this will compile. Oh wait, no it won't. Why won't it compile? Because this is a let. We're passing this thing in, and it's implied that this is a let. And not only that, it's not, because these are structs, right? They don't have a reference to the outside world. So even if you were to like override the default and turn this into a variable and change it, it's not going to change these, because the whole point of structs is that they are copies of one another, right? This is just a copy. It has no reference to the original source, which is, right, a problem. We would toggle this one, but the actual posts, when it changed in our UI, would not change, because it's actually, we want to affect the posts in this array, not some copy of the post. You could use, right, I showed you there's the, I think it's, let's see, is it here? You have this in-out thing. But that defeats the whole point. We want this separation of concern and structs and creating copies and all of that. So how do we do this? Well, we need to affect the actual array up here. And so we want to do is posts, and we need some index. We need to find which one of these is the right one. And then once we have, some index, then we can say is favorite toggle. We'll finally get there. But how do we get this index? Well, that's what we need to figure out. So we can say let post index equals posts dot first index. So there's this first index where thing. And it's just sort of a way to find like the first index where certain conditions meet. So we want the first index of these conditions. And you've used these things sort of like a filter used in the landmarks app, things like that. Similar idea. So we'd say first index. And again, this is like the explicit, but if we press enter, now we get the shorthand, right? So it just changed. And so now we're looking at, okay, what is that thing that we're looking for? And we'll just call it P for post, short for post, but not to confuse with, right? This is the post that we're passing in. This is a post which is inside these posts. We want to figure out, we want to match them somehow. Well, how do we match them? Do we look at their names? Do we look at, well, no, because there might be duplicates. We need a unique identifier, right? Well, we already have one. We have ID because, you know what? Post is identifiable. This is why it's required for post to be identifiable, and it's great and it's helpful in all these ways. It must have a unique identifier. So we can use this to our advantage. So we can say, okay, we want to find the first index where some post in here matches, where the ID of one of these matches the ID of the one that we've passed in. So we'd say p.id equals equals, right? Because we're not setting, one equal would be setting a value, but we are checking for equality. So we need 2, and we say post.id. So this is now giving us the index when these things match. But there could be, let's say, if we write our code well, this won't happen. But if someone were to make up something weird and they threw in a post that had an ID not in one of these arrays, which could happen in more complicated apps, it's possible that this would fail. It would run through them all and say none of these match. And this would no longer exist. So this right now is called an optional. And we're going to learn about optionals next week. But just as a preview, this could contain something or it could not, depending if this succeeds. So we want to make sure that this optional is actually a thing. And we'll talk more about this syntax next week, but for now, just know that we use this little guard syntax to guard and make sure that we actually have found an index, that it didn't just fail at finding it. So we will say actual index. We create a new variable, and this is equal to that post index. And if we don't find something, we just return. We say else return. So this is checking basically to make sure that this found something. It's saying, okay, if you did find something, call it actual index. But if you didn't, then just return. Just quit, give up. This function, isn't working. And you might throw an error, right? If you wanted to be more detailed, you might create an error message of some kind and say what happened. But we don't need to do that in our case. When we get to networking and you have things coming over the network, this will be very relevant. All right, but for this case, now all we need to do is this actual index is our index, and we can copy and paste it in here. So we finally have our logic. We finally have an index that we are going to change the toggle of the favorite, and yet it still has an error. It still doesn't work. let's build again to refresh. What is this error? Why doesn't it work? Well, it's because we are mutating this variable in this struct. And with a struct, you have to be explicit. With a class, this could just happen and you might not know. But in a struct, you must be explicit and say this is a mutating function. And this is actually quite helpful when we think about organizing our code. And so one way to think about this is all of the logic, all of the thing in your code, if you're ever changing the model, it should only ever be a mutating function that lives inside the model. And so you can imagine there would be a whole bunch of these different mutating, right, func. And we would say like add item, right? Something like that. And then we might have another one, you know, mutating func, delete item. So all the stuff that you want to manipulate your data, or if you have like a network connection, right? And we have some func, you know, get posts from network. Okay, and then what it would do is then call the network, you know, would not be a mutating function, but inside here, then we would call add, you know, item, maybe multiple items, right? And then this is a mutating func. So by doing it this way, it organizes all your stuff. It's now just here in the model, and we know if we're mutating the model or not. It becomes very explicit, very clear. And so you might be wondering, well, shoot, why did I do all of this stuff just to toggle a frickin' variable, right? Well, because if this were a real app and you're actually connecting over the network, for example, think about it. Just as simple as simply as like liking a like button in Instagram, toggling something. It's not just toggling the thing on your local, you know, mobile app, changing the UI. What you would do here, right? Before you do here, you'd have to call the network, actually. You would come here and you would make some network call, right? There'd be some other func to call network, you know, toggle favorite, you know, on server. My capitalization is wrong because I just typed, right? And you would need to call this function, right? And so then it goes over the network and it does, and then it would respond, and then you would respond, and then you would finally toggle your favorite, and then the view would update. So even these simple things actually do become complicated, and that's why it's important to follow this pattern to get your logic organized and in this spot. You would not want, you know, all this stuff, network stuff in your view, right? Or even your view model. You can imagine cluttering that up. It would just become a mess very, very quickly. So that's why we do it this way. All right, so we finally have our mutating. Let's see, did I erase one too many things? Let's see, we got this. No, that looks good. Okay. We finally have all that. We can make changes to our model. We still have this error. I'm actually, because, you know, I made all the changes, but I forgot up here, I forgot to remove this. I meant to do that, you know, earlier. That's why our compiler was confused, actually, and it wasn't showing these other errors. So if we build it now, it succeeds. But just to show you what I meant to, if we lose this mutating part of our function, right? If I try to build it, it doesn't work. Cannot use mutating member on immutable because self is mutable. So we say mutating. So we add mutating. Let's build it again, and the error goes away. All right, I think we are done with our refactor. So what you can see is we have a two-way publish connection to the model, but then our view model is serving as gatekeeper. It's only allowing the view a one-way, it's a read only, right, to the model to be able to see the posts. And then it's also a one way to change, but it's just through this function, and the view doesn't know how it's done, and even the view model doesn't know how it's done. It just passes this information along. So it's serving as gatekeeper here, and we've isolated, what can do what, and the only logic that changes is inside the model. All right, so let's just kind of wrap up. Let's go ahead and bring our preview back and sort of make sure that everything looks good. All right, so we can see the design that I did, which was to add a star button in the upper right-hand corner, was successful. It's still within inside our paddings. Of course, it was helpful because I did this before, right? But we can tap on it, and indeed, it is filled, right? So we can set our favorites, and even we've scrolled off screen, right? So those things might be, but they're still there. We can scroll this, we can undo it, and we can see it's still filled and it's still not. So we can view the thing and we can change the thing. And it's all been refactored with our view model, which is this state object added to the environment object. And in our project, we have our nice little folders with all those things. All right, so hopefully that's helpful, and I hope that you can apply the same pattern and these same principles to your homework. It very much is the same idea, only instead of just toggling, right, you'll need to do the same thing, but you will need to add, right, you'll need a function to add an image. We'll add a whole post, rather, with the image taken from the photo. And then you'll need something to remove a photo, and you'll need to add a delete button onto each row if it's, right, the author is the signed in user. So that's all. Any questions? Feel free to reach out. I will be traveling for a bit this week, so it might be a little delayed on responding, but I will try to get to everybody as soon as I can. So, all right, that's it. And I hope you all have a great week. Hope you have a great spring break. Reminder, there's no class, and I'll send another announcement. And yeah, you just get this extra lecture for free for spring break. So don't you feel so lucky? All right, later.